Hey guys, so this is the other velocity graph from the back of your study guide, and we are making a position graph as well as an acceleration graph, and you do have to do this on your test, so please make sure you know how to. All right, so let's start with position graph. I've already colored in each of the different shapes, so we've got a triangle, a square, triangle, and then one large triangle, all right? And remember, you are finding the area between your x-axis and your line, all right? So like all this crap down here, we don't care about the area there. Right, so for our orange triangle, you have an area of 3. For the blue box, you've got an area of 6. For the other triangle is also an area of 3, so same size. And then for this pink one here, you can divide it up at like split at 8 seconds, and you'd get a triangle, a box, and then another triangle. And you're gonna get the same answer if you do that. You're just doing a little bit more work. So I recommend keeping it one large triangle. And you can determine that based on the fact that this line is continuous, all right? It doesn't change. We're splitting this up every time our line changes. So it goes like here, it changes direction, here, here it crosses over the x-axis, so we've got to split it there. And then it's continuous the rest of the way, right? So our areas tell us how far up or down we're going to go on our position graph. If it's positive, you're going to go up. If it's negative, you're going down, all right? And then you're going to look at the shapes of the direction of these lines to determine, what kind of shapes you're going to make here. So our first area is 3. So at 2 seconds, you're going to be at 3. This diagonal line, when it's going away from your x-axis, means you are speeding up because you're starting at a speed of 0. You're ending at a speed of 3. So you want a curve that's speeding up, all right? From 2 to 4, we have a horizontal line. So we're going to go up 6 more because that's our area. So we're at 3. You're going to end at 9. And this is a diagonal line, even though it's not perfectly straight because I freehanded it. So you're going to have that continuing up. So now we're at 9 meters. Then from 4 to 6, we're again going to go up positive 3. Even though this is headed down, you are still going to go up, all right, because it's positive area. So you're at 9, you're going to now be at 12 at 6 seconds, and you are slowing down. So the fact that this is headed towards your x-axis, that means you are slowing down, all right? So we want a curve that flattens out in the end, all right? Because when they're flatter at the ends, that's when you're slowing down. When they're steeper at the ends like that, that's when you're speeding up, right? So then here at 6 seconds, this is where we cross the x-axis. That's where you're going to start going down. So like whenever you cross an x-axis, you're going to change which way you're going on your position graph, whether you're going up or down, right? So we were positive, now we're negative. So we're going up, now we're going down, all right? So then our large triangle has an area of negative 12. That negative tells we're headed down. We're at positive 12, so when we go negative 12, we end up back at 0. Since this is starting at a speed of 0 and we're increasing down to 6, we are speeding up. Remember that negative part of this tells you that you're going in the negative direction, right? The speed you would be going is actually 6. So you are speeding up to a speed of 6, which is not fast at all. But you are speeding up, so you're going to have a curve that gets steeper towards the end, all right? So that's your position graph, also called a distance graph, all right? Then for your acceleration graph, which to me is the easier graph to do as long as you're good at slope, you're going to find the slope for each section, all right? So we've got this first one is going to be a rise of 3 because it's starting at 0, ending at 3, and it's going for 2 seconds, so your slope is 1.5. Then anytime you have a horizontal line, your slope is automatically 0, so you don't even need to show the work because like you're smart enough to know that it is 0. Now the rest of this way, technically, it is one continuous line. So while I showed the work for each part, you could be smarter than me and do the whole thing all at once if you wanted to, right? So the whole thing would be starting at 3 and ending at negative 6, which would be a rise of negative 9. Now see, I did negative 3 and negative 6 separately, and then 2 seconds and 4 seconds. So it could be negative 9 and over 6, which would still equal negative 1.5. So you see here on my acceleration graph, let me make this a little bit bigger for you. All right. It is all at negative 5 the entire time. All right. So it continues the whole way. All right. So we've got it marked at our slope values. We've got it at positive 1.5. We've got it marked at 0. And we've got it marked at negative 1.5 the entire time. So that's easy as long as you can figure out the slope. So let me know if you guys have any questions because you are going to be doing this on your test. Each graph is going to be worth 10 points. I would count partial credit, like each section of this would be worth like 2, and then same here. All right, so I'm looking for the correct shapes, correct numbers. I'm looking for, correct numbers really here. All right, there's not as much partial credit I can really do there because it is kind of easy. So, but let me know if you have any questions in class before we take the test. All right.